Good morning to all of you. So today's topic is very interesting, that is Chateliers principle. So Chatelier principle plays very important role in equilibrium because it defines the equilibrium, that how the equilibrium is moving, and either it is moving in the forward direction or in the backward direction, and why it is moving. So first of all, we will talk about equilibrium. Like, what is the equilibrium? Equilibrium is that state at which the concentration, then concentration, you can also say amount of the reactants and products, temperature, pressure remains constant. What if we increase or decrease the concentration, pressure, temperature, then how the equilibrium will be disturbed? That we will study in under Chatelier principle. So Chatelier principle is a very important principle which will help us to study the shift of the equilibrium either in the forward direction or in the backward direction. So first of all, let's start with the definition of the Chatelier principle. So here you can see it is written that change in any of the factors that determines the equilibrium condition of a system will shift the equilibrium in such a manner to reduce a counteract effect of the change. इसका क्या मतलब है? इसका मतलब ये है कि जब भी कोई चीज़ इक्विलिब्रियम में है, फॉर एग्जांपल ये एक रिएक्शन है, ये इक्विलिब्रियम में है, अब अभी मैंने इसमें कुछ चेंज कर दिया, फॉर एग्जांपल आई हैव चेंज्ड इट्स कंसंट्रेशन, or I have changed its temperature or pressure whatsoever, then in that case what will happen to the equilibrium? It will not stay in the equilibrium, it will be disturbed. It will either go in the forward direction or in the backward direction, and after some time again equilibrium will be attained back. So that change of forward and backward reaction is actually happening so that the equilibrium is again attaining, and again it is coming. So for that Chatelier principle we will study. So first of all, the very first point we will study is the effect of change of concentration. Concentration is very important in case of equilibrium. We always study the change in concentration. We did numericals also on it, that if we are changing the concentration, then how equilibrium constant is disturbing, or what is happening to the K value, what is happening to the reaction. So let's study in case of hydrogen, iodine and 2HI. So यहाँ पे अगर आप देख रहे हैं कि हमारे पास हाइड्रोजन है, आयोडीन है और 2HI है, और ये इक्विलिब्रियम में है. अभी मैं एग्जाम्पल के साथ करूँगी. फॉर एग्जाम्पल अभी मैं क्या कर रही हूँ, अपने रिएक्टेंट्स में कंसंट्रेशन इंक्रीज कर रही हूँ. पहले तो अभी हम बात करते हैं कि इक्विलिब्रियम स्टेट में होता क्या है. आर हाइड्रोजन इज कलरलेस गैस, इट इज कलरलेस गैस, एंड आयोडीन इज वॉयलेट इन कलर, राइट, and our H is again colorless. So at equilibrium position the color will be not either violet not colorless, it is very mild color you can see at equilibrium. But what if you are adding more iodine? अभी मैंने क्या किया, equilibrium state पे तो था ही, लेकिन मैंने अभी iodine और add किया. आयोडीन ऐड करने से क्या हुआ कि इक्विलिब्रियम डिस्टर्ब हो गया, और वो जो रिएक्शन मिक्सचर था वो अगेन मेरा वॉयलेट कलर का हो गया. नाउ वॉयलेट कलर पे होने के कारण अब ये रिएक्शन जो है वो फॉरवर्ड मूव करेगा, सो दैट आपका जो कंसंट्रेशन आपके रिएक्टेंट्स में बढ़ा है तो वो फॉरवर्ड अगेन प्रोडक्ट्स की तरफ जाएगा, और प्रोडक्ट्स आपके जनरेट होंगे, और आफ्टर सम टाइम आपके यहाँ पे फिर से इक्विलिब्रियम जो है वो जनरेट हो जाएगा. So very important point, if you are increasing the concentration of the reactant, then equilibrium will be shifted towards the forward direction. आपने हमेशा सुना होगा दैट जो पानी है वो फ्रॉम पहाड़ों से प्लेन्स में आता है. आपने जैसे फॉर एग्जांपल डिफ्यूजन में पढ़ा है कि फ्रॉम हायर कंसंट्रेशन टू लोअर कंसंट्रेशन चीज़ें मूव करती हैं. वैसे ही इक्विलिब्रियम में जहाँ कंसंट्रेशन ज़्यादा होएगी वहाँ फ्रॉम हायर कंसंट्रेशन टू लोअर कंसंट्रेशन ही इक्विलिब्रियम जो है वो शिफ्ट कर जाएगा. मीन्स अगर मैं रिएक्टेंट्स की कंसंट्रेशन इंक्रीज करती हूँ तो जो रिएक्शन है वो फॉरवर्ड जो है वो शिफ्ट कर जाएगा. एंड वेरी इंपॉर्टेंट पॉइंट इज दैट what if I am increasing the concentration in products? For example, अभी मैंने क्या किया कि HI और रिएक्शन मिक्सचर में डाल दिया, ठीक है, रिएक्शन जो मिक्सचर था मेरा उसमें मैंने HI डाल दिया, मीन्स प्रोडक्ट्स की कंसंट्रेशन इंक्रीज कर गई. अब रिएक्शन कहाँ मूव करेगा, फ्रॉम यहाँ पे कंसंट्रेशन इंक्रीज कर रही है, अब यहाँ कंसंट्रेशन डिक्रीज कर जाएगी ऑटोमेटिकली. अगर यहाँ इंक्रीज करी है तो यहाँ डिक्रीज कर जाएगी, तो रिएक्शन विल मूव बैकवर्ड. मीन्स इफ आई एम इंक्रीजिंग द कंसंट्रेशन ऑफ द प्रोडक्ट्स, then the reaction is moving in the backward direction. So it is very important that if I am increasing the concentration of reactants, if I am increasing the concentration of reactants, then reaction is moving forward, means equilibrium is shifting towards forward. If I am increasing the concentration of the products, then reaction is moving backward. So this is a very important point in case of Lee-Chatelier principle. Let's take one more example, that is ferric ion and thionate ion and FeSCN. We know that the thionate ion is very purple in color and it gives us brownish color, reddish brownish color, and at equilibrium we get the brown color. So with the help of colors and observation you can define the concentration. For example, if you are getting purple color, that means the reaction containing reactants. If it is converted into reddish brown color, that means products are formed, and if brown color is present, that means equilibrium is present. And what if I am adding, now again Lee-Chatelier principle we will apply, what if I am adding more reactants? For example, I have added more thiocyanate in the reactants, then the reaction will shift towards the forward direction, right? फॉरवर्ड डायरेक्शन में वो चला जाएगा. फॉरवर्ड डायरेक्शन में जाने के बाद थोड़े टाइम के बाद वो मीन्स फॉरवर्ड डायरेक्शन में जाएगा, दैट मीन्स हमारा रिएक्शन मिक्सचर अब रेडिश ब्राउन में कन्वर्ट हो जाएगा. एंड व्हेन इक्विलिब्रियम इज अटेन, देन वो अगेन वापस आपका जो है वो ब्राउनिश हो जाएगा, मीन्स इक्विलिब्रियम आपका अटेन हो चुका है. फ्रॉम कलर्स यू कैन गो फॉर द अंडरस्टैंड अबाउट द इक्विलिब्रियम कंडीशन. What if I am changing the color of, what if I am putting more ferrothiocyanate? If I am putting more this, then what will happen? Then again the reaction mixture color will become reddish brown, and I have told you that if we are changing the concentration, if you are increasing the concentration of the products, the reaction will move from बैकवर्ड टू फॉरवर्ड. मीन्स आपका ये रिएक्शन है ये आपका बैकवर्ड चला जाएगा, मीन्स आपके जो है रिएक्शन में वो बैकवर्ड मूव कर जाएगा. बैकवर्ड मूव करने के कारण क्या होगा, आपका मोर एंड मोर आपका ये वॉयलेट कलर आ जाएगा. एंड आफ्टर सम टाइम एक ऐसा टाइम आएगा वेयर द कंसंट्रेशन ऑफ द रिएक्टेंट एंड प्रोडक्ट अगेन बिकम्स इक्वल एंड इक्विलिब्रियम विल बी अटेन्ड. सो दैट इज ऑल अबाउट द इफेक्ट ऑफ चेंज ऑफ कंसंट्रेशन. Thank you so much. Good morning to all of you. So our next topic in Lee-Chatelier principle is effect of change of temperature. So previously we have studied the effect of change of concentration. So we have studied that always the change in equilibrium will take place from higher concentration to the lower concentration. Same in that way, if we are changing the temperature, then equilibrium will shift same like before. It will shift from higher temperature to the lower temperature. Now we will take some example and then I will tell you and explain you every example like how the equilibrium will shift. So first of all, before understanding the effect of change of temperature, we should know there are two types of reactions present. Number one is exothermic reaction and number two is endothermic reaction. So first of all, what is exothermic reaction? Exothermic reaction is the reaction in which the heat is released in the reaction, in the products. Means when your products are formed, it is formed along with the release of lot of energy, lot of heat. And what about the endothermic reaction? Endothermic reaction is the reaction in which the heat is absorbed, and when your products are formed, the temperature gets very, very low, and that means the temperature decreased very, very much. So that is the endothermic reaction. So these two concepts we will take while explaining the effect of change of temperature. So let's start with the exothermic reaction and endothermic reaction. I'll take their examples. So first example is, you can see it is nitrogen plus hydrogen gives 2 ammonia. So when you see this reaction, actually I have written on this equilibrium is that when it is going exothermic, and if it is going forward direction then it is exothermic, and if it is going backward then it is endothermic. Actually I will explain both this process in this reaction. First of all, this reaction is exothermic reaction. It is actually, you can only know while performing the reaction. While performing the reaction, the heat is released in products. So according to thermodynamics, when we have to show the heat released, then you show with the sign. For example, in this reaction, the heat released is amount of minus 92.38 kilojoule. Minus sign signifies the release of heat. Okay, negative sign is the convention used for the release of heat. So in this case you can see delta H is negative. How you can come to know? It is the standard value. You can only come to know about this value while performing the reaction. So when this reaction takes place, then heat is released along with the product. That means the reaction of the product, when there is a beaker of the product, it will get heat up. That means more energy is released. So what will happen? I told you, just like the concentration, the reaction equilibrium shift like from higher concentration to lower concentration. Same in this case, the reaction will shift from the higher temperature to the lower. Means the equilibrium will disturb. It will get disturbed. क्योंकि बहुत ज़्यादा हीट रिलीज होगी है प्रोडक्ट्स में, तो जो रिएक्शन है वो कहाँ शिफ्ट कर जाएगा? रिएक्टेंट्स की तरफ शिफ्ट कर जाएगा. मींस बैकवर्ड चला जाएगा रिएक्शन. ओके, मींस इक्विलिब्रियम तो डिस्टर्ब हो गया. अभी अब आपको क्या करोगे ताकि वो रिएक्शन जो है वो आपका इक्विलिब्रियम स्टेट में वापस आ जाए? वेरी इजी. आपको क्या करना पड़ेगा? टेम्परेचर कम करना पड़ेगा. ओनली देन द रिएक्शन जो है वो फॉरवर्ड की तरफ जाएगा और कुछ टाइम के बाद इक्विलिब्रियम अटेन हो जाएगा. मींस आपको आपको एंडोथर्मिक कंडीशन डालनी पड़ेगी. आपको जो है वो रिएक्शन मिक्सचर को ठंडा करना पड़ेगा बाय गिविंग कूलेंट्स टू इट, ताकि जो है रिएक्शन, जो प्रोडक्ट्स का टेम्परेचर है वो कम हो जाए. प्रोडक्ट्स का टेम्परेचर कम होएगा तब जाके रिएक्शन जो है वो क्या जाएगा? बैकवर्ड जाएगा. और इस तरीके से जो रिएक्शन है वो इक्विलिब्रियम स्टेट में आ जाएगा. दैट मीन्स जब आपका रिएक्शन में प्रोडक्ट्स में एनर्जी रिलीज हो रही है तो रिएक्शन कहाँ जा रहा है? बैकवर्ड जा रहा है. और जब आप उसको कूल कर रहे हो तो रिएक्शन कहाँ जा रहा है? फॉरवर्ड जा रहा है. तो ऐसे ही आपको पता है इक्विलिब्रियम कब अटेंड होता है? व्हेन द रेट ऑफ फॉरवर्ड बिकम्स रेट ऑफ बैकवर्ड. तो उस स्टेट में फिर से वापस इक्विलिब्रियम अटेंड हो जाएगा. ओके, let's take one more example. Same in case of CO and H2, it will gives methane plus water. So this is the reaction of water gas. It is called water gas. So in this case also the energy is released. Means that means the temperature of the product will increase. Means reaction will go backward. एंड इफ़ यू हैव टू मेक इट अगेन फॉरवर्ड, बिकॉज आपको तो फॉरवर्ड ही करना है ना रिएक्शन को, क्योंकि आपको तो प्रोडक्ट चाहिए. अगर आपको वापस फॉरवर्ड लेके आना है रिएक्शन को, अगेन यू हैव टू डिक्रीज द रिएक्शन टेम्परेचर सो दैट इक्विलिब्रियम इज अगेन अटेन्ड. ओके, next example is this. 2NO2 gives N2O4 gas. So it is reddish brown in color and it is colorless. So you can here with this example you can visualize and you can observe by visualizing the reaction mixture. For example, if your reactants are present, then the beaker will be reddish brown, and then when products are formed, the beaker color will change into colorless. And along with the formation of product, the beaker temperature will increase. If you are touching the beaker, it will be very much heat up. That means when products are formed, it is exothermic reaction and beaker's temperature increases. If you have to decrease its temperature, you have to put that beaker inside the coolant, and when you add coolant, the reaction will go backward. So when the reaction will go backward and forward, when the rate of forward and backward become equal, then again equilibrium will be attained. So according to Chatelier, when the temperature is increased in products, the reaction will go to backward direction. Okay, in case of exothermic reaction, the direction of the equilibrium will shift towards the backward. Now let's take another example. What if the reaction is endothermic reaction? Means the reactants in case of products, the energy is absorbed and the product beaker become very cool. So in case I have told you, in that case the reactant's temperature is automatically high and product temperature is low, so it will automatically, obviously it will move towards the forward direction, because if its temperature is low, obviously means its reactant temperature is high. If reactant temperature is high, that means the reaction will move in the forward direction. So it will give you this CuCl4 to negative water. What if you want to make it again in the backward direction? Then you have to increase the temperature of the products, only then it will go to the backward direction. So in that case also, if the rate of forward and backward becomes equal, then again equilibrium can be attained. So that is all for the effect of change of temperature. So if I conclude with the effect of change of temperature, then if you are increasing the temperature then of the products, then reaction will move backward. If you are increasing the temperature of the reactant, then reaction will move forward. Means always the change in equilibrium will shift towards from higher temperature to the lower temperature. That is all about the effect of change of temperature. Thank you. Good morning to all of you. So my next topic is, in Le-Chatelier principle, is effect of change of pressure. So we have studied the effect of change of concentration and effect of change of temperature, and now there is a turn of effect of change of pressure. So very important in case of pressure, you know, if we are increasing or decreasing the pressure, the number of moles get affected, okay, and number of moles of gases get affected. Why gases? Because for example, you are taking one beaker and there are gaseous molecules in it, and you are taking one piston. So if you are applying pressure with the piston, so gaseous molecule will come close to each other, and maybe they will come that much close to each other that from reactant they form products, right? So in case of gases only we will take number of moles, and the effect of change of pressure will be seen only in case of gases. Okay, this is a very important point, that only we will take the effect of change of pressure for gases in any reaction. And we will study the number of moles in that. Let us take some example. I have taken this example, hydrogen plus iodine gives 2Hi. So here you can see all are in gaseous states, right? So in this side there are 2 moles, on other sides there are also 2 moles. So there are number of moles on right hand side and left hand side are equal. So there will be no effect of change of pressure, okay? There will be no effect of change of pressure. Let's take another example. Here also you can see in this reaction example, that is carbon dioxide plus hydrogen gives CO plus water. Here also number of moles in right hand side and left hand side are same. So here also we cannot study the effect of change of pressure. Here also there is no effect of change of pressure. Next, let's take one more example. Here you can see there are total 4 moles of gases. Only gases we will consider, right? So here total 3 plus 1, 4 moles, and here there are 2 moles. So always if we are increasing the pressure, if you are giving pressure, means you are increasing pressure, the effect of change of pressure will be seen if there are change in the number of moles in right hand side and left hand side. For example, here there in the reactants are 4 moles and in products are 2 moles. So if you are increasing the pressure, the reaction will shift from higher number of moles towards the lower number of moles. Means here the reaction will shift towards the forward direction, right, in order to attain the equilibrium. Why it is shifting? In order to attain the equilibrium. So it will shift towards the forward direction. Let us take one more example, that is here you can see one more example is there, carbon solid, carbon dioxide gas, it gives 2 CO2 gas. So in this reaction we will not take the number of moles of solid, because we have only to take the number of moles of gases. Why? Because pressure can be applied only for gases, right? So in case here the total number of moles are 1, in products it is 2. So number of moles are higher in products. So always if you are applying the pressure, if you are increasing the pressure, the reaction will obviously move towards backward, because from higher moles towards the lower moles, so it will move towards backward direction in order to attain equilibrium. So this is the effect of change of pressure. Same if you have to study the effect of change of volume. You can also study the effect of change of volume here only. How you can study the effect of change of volume? Because according to Boyle's law, you know pressure is inversely proportional to volume, right? So if you have to study the effect of change in volume, again you can study just like pressure only. In case of pressure, whatever it was from higher moles to lower moles. So in case of volume, it will be the reaction will shift from lower moles to higher moles, because it is inverse relation. So if for example here I am applying volume effect, so what will happen, the reaction will shift towards the backward. Where it will shift, it will not shift towards the forward, it will shift towards the backward, from lower moles to higher moles. That means in case of pressure, the shift of the reaction is from higher moles to lower moles, but in case of volume, the shift is towards the lower moles to higher moles. That is all about the effect of change of pressure and volume. Thank you. So next is effect of change of addition of inert gas to the reactants. Okay, so we will study the effect of Le-Chatelier. So inert gas we are adding, inert means non-reactive and gas ऊपर से, ठीक है, gas is there. So if we are adding inert gas, so what will happen in the change of addition of inert gas? So we will study the effect of change of addition of inert gas in two conditions. Number one is at constant volume and number two is at constant pressure. So let's start with the at constant volume. In case of volume, you can see if we are adding inert gas in case of at constant volume, what will happen? Inert gas, there will be no change in the concentration of the reactant, because inert gas will not participate in any kind of reaction. It is already non-reactive, so it will not increase or decrease the concentration of any of the reactant or product. So at constant volume, there will be no change in the concentration of the reactants. So that's why if you are adding the inert gas at constant value, so at constant volume, there will be no effect. There will be no effect of it, and there will be no disturbance of the equilibrium. Okay, so this is a very important point. Next is, what if we are adding the inert gas at constant pressure? So inert gas is a gas. It is a gas, so it will also create pressure, and already we are taking pressure. So what will happen? So it will at constant pressure we are talking, but it will affect the equilibrium at constant pressure. How? Same in case of pressure, like in pressure, effect of pressure we have studied that the reaction will shift from higher moles to lower moles. Same in this case also, the reaction will shift from higher number of moles to lower number of moles. Let's take one example. In this case, 2 sulfur dioxide gas, this is a gas, and oxygen also a gas. Then if this reaction is taking place, then you can see there are number of moles. There are 3 moles and there are 2 moles. So reaction will shift towards backward or forward. It will shift towards forward, from higher number of moles to lower number of moles at constant pressure. So this is the effect of change of addition of inert gas. Last is effect of catalyst. So there is no, I have already told you that there is no effect of catalyst at equilibrium, because catalyst only increase the rate of the reaction, but it does not itself participate in the reaction. So it has no effect on the equilibrium. So according to Le-Chatelier, there is no effect of catalyst on the equilibrium. So this is all about the Le-Chatelier principle. Thank you very much.